And this is in very center of our secure project, where we are trying to build optimization algorithms for which we want to include some form of data privacy. The example could be water consumption, where water utility might want to know how much water does Aalborg City use at 4 o'clock in order to prepare the tower tanks and have some access of water, turn certain valve pumps and so on and so forth. One of the examples could be to have 3 houses and figure out how much these houses use of water during a specific period of time, say 1 day. And the task is relatively easy. The task is easy because you take sum of what black house does, consumes, then you can take the consumption of the house with yellow bricks, what it consumes, and the same with house, the red house. And what we need to do, we just sum it. The problem is that one of those consumers does not want to share the data. Somehow this is very valuable data for the consumer yellow, and we have to hide it in some sense. And to this end, cryptography has developed certain cryptographic protocol. In here I will present you with additive secret sharing, and I will show you how to do this without revealing any form of information. So I'll start with the initial information and come back with my bricks back to the houses. And the task is to sum it in some way. And we'll use a random generator. For me, it will be enough to use a dice. I do the following. Since dice, when I throw it, gives some random number, 5, I can transfer the information 5 to one of the servers. What does it mean, transfer the information? It means that I imagine that there is a line where secure information can be communicated without revealing any information. And you could ask, how much server 1 will know? Well, he doesn't know that much because it's just a random number. So it doesn't say anything about black consumption. Then I will throw once again. I will get again 5, and I will send it to the next server. And the rest I will send to the last server. And again, there are random numbers in each of those servers. They do not communicate with each other, so they cannot make a sum. They don't know how much black house was using during this day. We do the same with the yellow house. Again, I take 4, I throw the dice, I have a 4, and I send securely information to server 1. I throw it once again 4, I send it here, and the rest I send to the last server. I do again the same thing with server number, with the user number, not number, I code them with colors, so red, so it's a red user, and then 6, I pick 6 bricks, I send it here, I throw the dice, I have 3, I send it to the new server, and the rest goes here. And see, it looks pretty complicated, but what is the result? The result is that I sent random numbers to each of those servers. That is, no one has an idea how much each of those houses was using. And what? Now I can sum this. So what I do, I reveal this information publicly. I reveal also this information publicly. And I reveal this information publicly. Can I do this? Yes, because they are just sum of random numbers. Sum of random numbers is still a random number. So I have random number, a random number here. But if I sum those, I have a total consumption of all 3 houses. So this is an example of a protocol, additive protocol, which we use in our algorithm in order to hide information. Of course, this is a very simple example, and this shows only how to do addition, pluses. There are also protocols which, in a bit more complicated manner, shows how to do multiplication. As soon as you have multiplication, pluses, you can build algorithm for artificial intelligence, for optimization, for machine learning. Yeah.